Hi, this is Henry again, and today I'm going to expand on the last tutorial I did, and I'm going to take a surface, I'm going to map a hex grid on it, and instead of creating a component that gets sort of wholesale mapped onto the surface, I'm going to map the hex grid on, and then manipulate it directly on the surface, and then change it using an image map. So here is a surface that I just modeled in Rhino. No big deal. And I'm going to get a parameter, name it base surf, set it to our surface, turn its layer off. And next I'm going to need a hex grid, and under grid, hexagonal. And just to be consistent, I will make sure that it's drawn right directly at the XY origin. Now the size is not going to matter, but the number of hexes will. So let's set a slider. Get another slider here. Call that hexes U. Hexes V. Right. And so just like last time, what we need is an easy way of morphing these onto the surface. So the first thing we need to do is we need to get a reference surface. And I think the easiest way to do that is to get a bounding box and make sure that the bounding box is set not to per object, but union box. And you're going to have to flatten the incoming hex grid, right? And that gives you this one, you'll see if you mouse over it, flat box. So what we need to do just to get a surface out of that is we need to use deconstruct brep and then get a surface parameter and connect it to the F, or the face output of deconstruct brep. And that gives us one untrimmed surface, and we'll call this flat hex surface. And so now under transform, morph, map to surface. So map to surface is going to take our input hexes, and I'm gonna, I should have put these to a parameter. So let's call these flat hexes. And let's copy it up here, stick it into our C. Now the base surface is our flat hex surface. Right, that's the surface that the hexagons already live on. And then we're mapping it onto our, I called it base surf, but let's call it, I don't know, let's call it bubble surf. That's the thing that's forming this bubble that we modeled. All right, and then if you look over, right, you can see that, here's our hexagons mapped to the surface. And when we change the number, changes the number, the size doesn't matter because it's just getting remapped onto this surface. Right? So we need a parameter, and let's call these hexes. All right. So now what we want to do is we want to create a thickened surface, and we're going to create a thickened surface by taking each one of those hexes, and we're going to make a smaller hexagon inside of it, and then move it up off the surface. So let's look at how we could move the hexagon up. So the way we're going to do that is we want to make sure we move it not straight up, but that we want to move it up normal to the surface. So here's how we're going to do that. Each of these hexagons here And you know what? I'm going to just clean up. You can see the data tree is a little bit wonky. You got like 12 lists of 12 hexagons, I guess, because that's, or let's see. We've got 16 lists of 12 hexagons. I'm going to graft it and simplify it. So you can see that now you have a list of lists of one hexagon. Or another way of thinking about it is each hexagon has a kind of coordinate. You can see they go from 0, 0 to 16, 11. Okay, so now what I want is a sort of local center point and a normal vector. So a vector that points away from that surface. And here's how we're going to find that. So under analysis, we're going to get a polygon center for each one of these hexes. And then under surface analysis, there's something called surface closest point. So I'm going to take my bubble surface. Let's go back here and let's make sure that this is reparameterized. That's very important. I'm going to take my bubble surface and I'm going to take the output of kind of any one of these. These are just 3 different ways of calculating the center point of that hexagon. And that is going to give me, if I turn this off, that is going to give me a point that is definitely on the surface, that is closest to the center. And it's also going to give me the UV parameter of that point. That is to say, the coordinate relative to this surface. And that's important because if I go to analysis and I say, and I go to evaluate surface, where is it? Evaluate surface. And I use my UV point that I got by finding the center point of the hexagon, the closest point on the surface to the center point of the hexagon, and then the UV point of that point. Right? My outputs of evaluate surface include this n, which is a normal vector. So that's a vector that's pointing away from the surface. So if I go to parameter, where is it? It's geometry vector. So let's call that normal vector. So if I were to make another parameter and call that, one second, call that amplitude, hook it up to a slider or something. And then here under vector, vector amplitude, that will take a vector and a number, and it will set this number to be the amplitude of that vector. Right. So back over here, right, here are our hexes. If we were to go to transform Euclidean move, we could use this vector, right, to, that's very hard to see. Let me make this number a little bit higher. Right, you can see I'm using it to move my hexagons off of the surface. Right? And you can see there's some space in between them because when you move them off the surface, they no longer touch. But that's okay. So now what we want to do is maybe we want to scale these hexagons down so we get something like hexagonal cones. So let's do that. I'm going to just take this here and turn its preview off. Let's do that. Let's do that before. Let's do that again. Before we move it up. Right. So here again, here's my parameter for the hexagons. And here's my center point. Let's call that hex centroid. Right, so I could just scale the hexagons around that centroid. And actually, you know what? Maybe that's just the best way to do it. So go to transform, Euclidean, affine, scale. Right, and so that centroid, you can see when I mouse over, right? They've got the same data structure. It goes from 0, 0, 0, 1 all the way to 15, 11. Same with my hexes there. So the centroid, that's my center point. And the hexes, that's what I want to scale. Right, so now I have a bunch of hexes that have been scaled. And let's create a parameter. We'll get a slider. And we'll call this top scale. And let's put that in a parameter, and let's call that top hexes. Right, so now what if instead of moving our regular hexes, we move our top hexes? Right, so that controls the scale. This controls the amplitude. These are our top hexes. These are our bottom hexes. And if we wanted to connect them up with lines, right, we could do our old trick of going to division, divide curve. And so now this is useful, right, because each one of these is its own list of 1. And we could say n equals 1, but trim it kinks equals true. Then you get, if you mouse over it, you get 6 points, 1 at each corner. And if we do the same for the bottom hex, then we could simply go and create a line from the bottom hexes to the top hexes, right? So that's pretty cool, but it's kind of boring. And you know, all of my smaller hexes are controlled by the same scale parameter. Right? They can all be 0, they can all be 1, whatever. You know, maybe there's a way to make them vary. And there's all sorts of reasons why you might want to vary them. Maybe there are openings in a surface that react to the sun or different interior conditions. So here's one way to do that. What if you could vary them? And this is what we're going to do. We're going to just essentially draw a black and white map that we're going to use to vary them. So I'm going to do that in Photoshop. I'm going to open up Photoshop, and I am going to make a new image. Let's make it 400 pixels by 400 pixels. And I'm just going to make a simple gradient. I'll use the gradient tool from white to black. Oops, set to go from white to white. Let's try that again. White to black. Oop. One more time. There we go. And I'm going to save it as gradient.png. I'll just save it on my desktop. You can see I already did this before, but I'll save over it. And then over here, under in the params tab under input, there's a parameter called image sampler. So image sampler, if you right click on it, you can go to image down here and select our gradient. And you can see it appears, we read it in. And when you double click on it, you can see it has its own domain from 0, 0 to 0, 1. And like down in the lower left-hand corner, that's like 0, 0, and up in the right-hand corner, that's like 0, 1, or that's like 1, 1. So it's just like a surface. And in the same way that you can map points to a surface in a domain from 0, 0 to 1, 1, you can map points on this image. And so you can evaluate the image at any point along it, just like you evaluate a surface. So the question is, what's the output going to be? And if you click over here on color brightness, because it's a black and white image, it means it's going to output one number, and that number is going to be from 1 for white to 0 for black. So if you can evaluate this image the same way you evaluate a surface, well, that's what we're doing over here. Where is it? Over here. We're evaluating the surface based on a point, and that point is the center point of each one of our original hexes. So what if we took that to a parameter? Call that UV coordinate of hex center point. Right, we can even plug it back into that eval surface. Right, and so that's a point in UV space, and we can use that to plug into the left side of our image evaluator. And you'll see what comes out the right side is a series of numbers, and those numbers represent the color, with 1 being white and 0 being black, of the image at that coordinate. So that means, right, this is the image brightness. If we were to use that as our scale, right, because scale takes a number from 0 to 1, now all of a sudden you can see that the openings are much bigger over here and much smaller over here. You can see that it's failing, and it's failing because the openings go to 0, which is why that turns red. So maybe what we need to do is we need to remap the numbers. Let's just do that really quickly. So remap the numbers. So this is our image brightness, which we know goes from 0 to 1. So our source domain is 0 to 1. So our target domain, that's going to be the domain of whatever we want the numbers, wherever we want them to fall. So if we construct a domain, we can put 2 sliders. One slider will be, let's call this the small val. And the other slider will be large val. And then we send our remapped numbers into image brightness. Right now they're all the same because small and large are the same. But you can see, right, if I slide that slider up, this slider down, right, and you know, it might help. Let's up the number of hexagons. Let's up it all the way, right, 25 by 25. And so you can see now, right, I've got very small upper hexagons on the left, very large hexagons on the right, which corresponds to my image. Right? If I wanted to do it differently, I could maybe set my gradient to be like a point, you know, a circular gradient. And if I just resave my image and I go back to Grasshopper, right, you can see now I have my large hexagon values where the image is white, my small hexagon values where the image is black. You know, if I were to do something like do a loft, right? I could loft from my bottom hexagons to my top hexagons. Right? And you can see now I'm creating a surface where I have more opening here, less opening there. You know, and if I wanted to start to shape that, we could go back to Photoshop here and sort of draw some places where I want it to be more open. Save it. Come back. Right, and you can see that's open, that's open, that's open, which corresponds to my image. You know, or if I wanted to do something different, You know, I could start to think about how I connect up these points. So right now, this is my list of points on the bottom. This is my list of points on the top. And what if I were to do something like sets, list, shift list, and make sure that wrap is set to true and shift is set to 1. So now that shifts the list over by 1. When I do this, you can see what's happening. Now I start to have these kinds of like swirly aperture shapes. Now, since I have a list of points, if I wanted to here, I could say polyline and make sure to say true for close. Right now, those are my new top values. So if that's my bottom, I hold down shift and that's my top, right? I can even do the loft. Oops, that didn't work. Let me hit simplify. That should do it. Yeah. Right, so I can start to build up, you know, quite a lot of complexity. Now you could imagine, for example, right here, this is how I took a single value and made many values for my scale. I could do exactly the same thing for my amplitude. So maybe they could move up and down in different ways. But I will leave that up to you.